So first lesson of the probability unit is about experimental probability, okay, which is the likelihood of an event occurring based on observations of a number of trials. So we're actually out there rolling the dice, flipping the coin, observing how many times the Sharkies win their games or whatever, actually out there doing the thing. And we'll find the relative frequency of an event, say flipping a head would be the frequency of favorable outcomes. Okay, so basically how often the event occurs divided by the number of trials, which is, I guess, the number of experiments that we observe. Okay, so as a simple example, we'll get some fact that there were cupcakes in maths twice and 28 times without cupcakes. I'm not sure which math class they're talking about. I don't think we've ever had cupcakes. Find the relative frequency that there will be cupcakes on Friday. Okay, so I'm trying to find what is the relative frequency of cupcakes. I'm going to look at what happened in the past to predict what's going to happen in the future. So I'll look at the frequency of favorable outcomes. How many times were there favorable outcomes? How many times were there cupcakes? There were 2 times. And how many trials were there? Well, if there were 2 times with cupcakes and 28 without, I need to add these together to look at how many trials I had altogether. So 2 on 30. And you can simplify this to 1 on 15, and you could either write it as a decimal, so put it in your calculator, okay, 0.066, or write it as a percentage. Okay, so we can read this as 1 in 15 classes, or 6.6% of the time, or 0.066 of the time. So that's relative frequency. Always just write relative frequency and in brackets the thing that you're trying to find the relative frequency of. Even better if you can write this formula on top there, which I definitely should have done. And we can use the relative frequency of an event to predict how many times it would occur in the next set of trials. So for example, I'm trying to find how many times I expect to get cupcakes in the next 5 days. I think it'll be 6.6% of 5 days will be the number of days that I would expect to get cupcakes. And that's what this is talking about, the expected frequency of cupcakes. So expected frequency of something like cupcakes. It would be the relative frequency of it. So either of these, I'd probably just choose the fraction so that I don't lose any accuracy, times the number of trials. Okay, so I would expect in the next 5 days to have cupcakes for 1/3 of a day. So not even 1 day. So realistically, you wouldn't expect to get cupcakes at all there. Okay, however, if I change this question to the next 100 days, it'd be 1 on 15 times 100, okay, which would get me hopefully a few more days of cupcakes. They get me about 6.6 days. So I'd expect maybe 6 or 7 days where there'd be cupcakes in the next 100 days. Okay, so another example, in Brisbane there's 300 sunny days in the year. Find the relative frequency of a sunny day. The relative frequency of a sunny day. Okay, this time I'll be a good boy and write the formula. I probably don't bother writing frequency of, so just favourable trials divided by number of trials. The favourable thing is a sunny day. That's the thing I'm interested in. It's not necessarily a good thing. Favourable trials, there were 300. How many trials were in the year? Assuming not a leap year, 365. And then we can write that as a fraction, simplified fraction, or a decimal. So let's simplify the fraction if we want. 60 on 73. And if you wanted to, you could write that as a decimal or percentage. How many sunny days will there be in November? So I'm thinking, what's the expected frequency of a sunny day? Okay, and I know that will be the relative frequency multiply the number of trials. So my relative frequency of a sunny day is 60 on 73. Number of trials, 30 days has September, April, June, and November. So there's 30 days in November. Multiplying these two things together will let me know how many days in November I should expect to be sunny. I'll expect 24.66 sunny days. Now, whenever we're finding expected frequencies, we won't round this because that might limit my ability to be able to use this to do more projections in the future. Maybe I want to know how many sunny days there'll be in Novembers for the next decade. I'd multiply this by 10, okay, rather than multiplying either 24 or 25 by 10. So there's also this thing called the rule of 5 about combining some frequencies, and in times, instead of, like in those previous examples, the information being given in words, it might be presented in a tabular form. So I'll look at both of those here. So if we have individual frequencies of less than 5, it'll produce probabilities or relative frequencies and expected frequencies which are unreliable. So for example, we're rolling a die, and we've got these outcomes. These two here are a problem because they're less than 5. So what we'd be required to do is to modify this table. It's called a one-way table. We just read it one way. We'll look at two-way tables later in the term so that it complies with the rule of 5. So what I'm going to do is combine these two outcomes. I'll write these other outcomes as they were with their frequencies. And what I'm changing is this outcome in the middle will be 3 or 4. And the likelihood of getting a 3 or 4 is the sum of these two, which is 7. Okay. What I can also do when it's in this tabular form is to find what the total number of trials is by adding all of these frequencies. There's 69 rolls in total. And then I can find the relative frequencies for all of these. So 15 on 69, 20 on 69, 7 on 69, all the way down. Okay, and hopefully when I add these all together, I should get 1 down here. Adding is your check, and all of these numbers in here, like this number 0.29, is the expected frequency, relative frequency of rolling a 2. Okay, so we've modified the table, that's done. It complies with the rule of 5 because all of these frequencies are greater than 5. Now we can use it to answer some questions. How many times would you expect to obtain a 1 if you're going to roll the die another 20 times? I'm looking at what is the expected frequency of getting a 1. So I'll have to look at what's the relative frequency of obtaining a 1 times the number of trials. Relative frequency of getting a 1 is 15 on 69. And I'm going to do another 20 trials. I expect to get it 4.35 times. Is the number of times I would expect to get a 1 in the next 20 trials. In a similar way, I can find how many times I'd expect to get 3 or 4, just using that third row in the table. You can do that one by yourself, about 2 times in the next 20 rolls. So from here, have a go at these questions. Make sure that you set out the problems correctly, because this is what shows people your thinking process. If you just have a whole heap of numbers like this, we don't know what you're thinking. You're not communicating very well why you're doing those procedures. Okay, so get into it.